So as you can see on the screen, we're here for a day in the life of a Netflix engineer. If you're looking for days of our lives, that's in a different room. There are some parallels to large-scale operations and soap operas, however. So as we start off, how does the world see Netflix? The world sees Netflix as a source of great content. We have those superhero shows, those lawyer shows, superhero lawyer shows. Romances, comedies, romantic comedies, things that are epically grand, and even a few things that are epically spooky. We also have a collection of political documentaries. How about prison documentaries? Actual documentaries. We have content about powerful women. We have content about retirees. We're going to have content about powerful women retirees in their natural habitat. And what I like to call our most unpopular Netflix series. I'm really hoping as we go into the next season, we update the box art that you see. But to be honest, that's not why we're here. We want to lift that cover a little bit. We want to look inside. We want to see what is Netflix like as a technical organization. What does it take to make all of this stuff tick? So this next section is called A Bite About Netflix. It used to be a bit about Netflix, but it's at least 8 times better now. Okay, the jokes aren't going to get any better, just like last year, for those of you who saw that one. So Netflix is a big data and telemetry company that has the byproduct of streaming video over the internet. Your Netflix experience is made up primarily of 2 pieces. Some of you may have heard of Amazon Web Services. There's another one of those jokes. We use Amazon Web Services for what you'd consider to be our control plane. This is where we do all those algorithms for deciding what it is we think you might like to see. All of our customer data and information and compute and batch jobs and decisions and customer interaction, all of that kind of stuff comes from Amazon. Now, the other half of your experience is actually watching the video itself. All of your video bits come from our purpose-built CDN called OpenConnect. A few years ago, we used to stream our video bits from the big 3 CDN providers. We had Akamai, Limelight, and Level 3. And as we grew and as they grew, there were a couple of things that diverged a little bit. Those companies are trying to be the CDN for everybody, so they want to distribute video and UI bits and content and HTML and all of those kinds of objects. So they have to create a service that really will distribute just about anything we can push over the internet. We didn't need that. We just needed video. There's also a second, more important piece. Anytime one of those companies places one of those cache boxes somewhere on the internet, they have to tie a profit profile to it. That box and its bandwidth costs them money, so they have to understand how they're going to make their money back on that particular investment. So they're profit-driven. Our goal with our CDN is experience-driven. We want to make sure that our customers have the best possible video experience they can have. So we started building and designing our own content distribution network. And we thought, you know what would be perfect? Let's put a cache box in everybody's house. There's a couple logistical problems with that. So we did the next best thing. We started installing these cache boxes right inside your ISP's network. So it does a few really nice things. It gives your ISP some of their transit bandwidth back. It also means that those video bits that you want to see are as close to you as possible, just a couple hops away, and you don't have to cross that border out to the internet in order to see that information. That allows us to do fun things like 4K and 4K HDR and 8K and 150K or whatever is coming next. So we've distributed these boxes all around the world. This is a look from, I believe, March this year, showing you where we've installed those caching systems and boxes. The larger the dot, the more systems we have there. This is out of date by a few months, and it's about 20% small for what actually lives out there in the world. I tell you this to get across an idea. Netflix is big. You really just won't believe how vastly, hugely, mind-bogglingly big it is. With apologies to Douglas Adams. So Netflix is big. What do I mean by big? Lots of, we're in a big room, right? The keynote rooms were bigger. The conference center itself is even bigger. So I really just can't say big. I need to tell you how I'm measuring and what I mean when I say big. So those of us on the cloud, we talk about how many instances are you running? We run more than 100,000 instances in Amazon every day. And that's actually now on the low end. Another measurement we talk about in computing systems is CPU cores. So we run more than 800,000 CPU cores every day to help provide you that Netflix experience. We're also big believers in auto-scaling. We do both the reactive auto-scaling offered as the Amazon service as well as predictive auto-scaling so that we have those resources available before that traffic shows up. We're really kind of aiming for that Goldilocks zone of not too much and not too little, but just the right amount. Auto-scaling is one of the things that helps us do that. And of those more than 100,000 instances, we will auto-scale up and down 20% of that capacity every day. So to give you another idea, this is a picture of the NASA Pleiades supercomputer. And they run a little, just a hair under 250,000 cores in that supercomputer. So based on the number of instances we run, and our proclivity for auto-scaling means that we build up and tear down the equivalent of the NASA Pleiades supercomputer every 2 days. Another measurement, how about traffic? We use ELBs as our front door. We run 50 gigabits of traffic consistently through those ELBs. And that's just on a per region basis. So we run a little bit of data. Something that I find kind of interesting. More than 25 gigabits of that traffic is your streaming devices talking back to us. As I mentioned earlier, we're very concerned with what our customers' experience is. Everything from the kind of content we pick to how you interact with the system to how the actual video streaming is going. So it's very important for us to get information back from your streaming devices about what they're seeing in either bandwidth capability, bit rates, all of those kinds of things. So more than 25 gigabytes of that traffic is just your devices talking back to us so that we can tune that experience and keep it as high quality as possible. Another statistic some of you may have heard is, at least in the US, at peak time, Netflix is responsible for a little over 37% of the US internet consumption. You're welcome. Or if you work for an ISP, sorry about that. So something else that's big. We have a lot of accounts, like many of you do. We have different accounts that we use for different things. We have a production account, we have a test account, we have a data persistence account. We have lots of different accounts. 4 of our accounts by themselves are actually large enough to be considered by Amazon enterprise-size accounts, each on their own. And that's just 4 of 50-some of our accounts. Our bill. Our bill is really big. Our billing file is hundreds of megabytes every month. It's over 800 million lines of information. There's a Hadoop cluster that lives at Amazon whose only purpose is to load our bill. So we talked some about big. Netflix is also fast. One of the things you'll hear Netflix people talking about is what we call the velocity of innovation. We consider speed to be a strategic advantage. So for instance, a few of you may have heard about, we launched a small new feature on our service this morning. You can now download and watch things offline. So you can now watch Netflix on an airplane, in the car, my favorite, at my mother-in-law's house. We had to develop that rather quickly. Everything we do is really about speed because bringing those new features to market, trying out new ideas, getting new content ready to watch for us is a strategic advantage. So much so that this is one of the things that we talk about regularly, the velocity of innovation. A few examples. Earlier this year at CES, our CEO announced we're going to go global right now. So we added 130 countries to Netflix availability that day. To give you an idea of what had to happen for that to come into place, we have to have content ready for each and every country. We have to have localization ready for a local language or languages. We have to be able to accept payment in local payment form. We have to have deals with banks. So we went from being in part of the world to this kind of global distribution. We added 130 countries in one day. I thought that was pretty fast. How about production changes? Something near and dear to many of our hearts, right? Our distribution system, Spinnaker, records about 4,000 production changes a day. And by that, I don't mean just flipping a database, a bit in a database. That's code production. Those are feature flags. Those are changes to the running environment, updated endpoints, all of those kinds of things. Around 4,000 a day. We get millions of new customers. So we have millions of new customers coming in from thousands of ISPs, from hundreds of new countries, from a myriad of devices, each one of those unique combinations being a new experience. And that happens for us every day. We stream billions of hours of entertainment. This is actually an older measurement that was common. For those of you familiar with Nielsen ratings, they talked about number of viewers and number of hours watched. So we've talked in the past about billions of hours streamed in a month. Currently, we've actually moved that now down to days. So to give you an idea, our peak day, we streamed over 125 million hours of entertainment in one day. It was a really long day. I'm kidding, it was 24 hours like every other day. So we've talked about a few things that are big, so let's talk some scale. So here's something that's big. This is a giant bucket wheel excavator. This is called the Bagger 293. The Bagger is 315 feet tall. It is 750 feet long. It weighs in at an amazing 14,200 tons. It can move 240,000 cubic meters of material every day. The Bagger is big. If you've ever had that experience where you get a little something stuck in your teeth, the Bagger had the same experience, except it was a full-size bulldozer that was stuck in its teeth. So the Bagger is big. So if you ever see the Bagger coming at you, don't walk, don't run, feel free to crawl away because it only moves about half a mile an hour. So about fast. This one's one of my favorites. This is the SR-71 Blackbird. The SR-71 Blackbird can max out at a hair under 2,200 miles per hour. So if you think about the distance, say for instance from St. Louis to Cincinnati, it's a little over 300 miles. Aboard the SR-71, you make that flight in a hair over 8 minutes. The SR-71 is fast. It is also not big. So big and fast often end up at opposite ends of the spectrum if they're even on the same spectrum. But we have the challenge of being both big and fast. So what things are big and fast? So maybe big and fast without extinction level events would be a good thing for us to shoot for. So we looked for that balance between big and fast and keeping our service available. Because it doesn't matter how many fancy new features I have, how many new bits of content I have, how many countries we launch in, if the service is not available. So we have to do big and fast and available. So I'm here to tell you we have that all figured out. We never have any problems. So the rest of my presentation will be pictures of cats I found on the internet this week. So perhaps that isn't quite entirely true. So let's talk about what do we do at Netflix in order to enable big and fast and still be resilient, still be available for our customers, still be able to provide fun new things like a download service. So some of the things that enable big and fast at Netflix. Some of you may have heard of the word chaos associated with Netflix. We have Chaos Monkey, we have Chaos Kong. I myself am a Chaos Monkey. But those pieces of software themselves are not the goals. They're not what's important. So we talk about the principles of chaos. So chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in that system's capability to withstand the turbulence of a production environment. In other words, chaos in practice is an inoculation against failure. Those things that wake you up in the middle of the night oftentimes don't wake us up in the middle of the night because we've done things to make sure that our systems understand how to behave in those situations. So let's talk a little bit specifically about the discipline of chaos. So the first thing we do is that we want to build a hypothesis. We want to understand the steady state of our system when things are working like they normally should. And we want to be focusing on what that system produces. So whether that's the amount of RPS that system can take, the number of widgets it can sell, the number of new members it can sign up. We want to understand what those statistics are at steady state. And while it's important to understand attributes of the system like CPU usage or memory usage, they're less important than understanding the steady state of your system actually doing the things that you want it to do. So that's your hypothesis. Then we want to talk about varying real-world events. So, I mean that very seriously. So for instance, I don't necessarily know how the Netflix system will behave in the event of a Martian landing, but I can tell you I know how it behaves in the event of a network partition, or enormous latency, or the loss of a region, or an availability zone, or microservice going down. So you want to look at those real-world events. Plan for reality and understand it, so when reality happens to your system, it knows what to do. And then you run the experiment. You make that change, whether you're looking for a smaller number of instances to see how many RPS we can squeeze out of this, whatever it might be. You run that experiment and you understand how your system behaves. You always do this, by the way, in your production environment. I saw a few people shiver. We all know that there are times that there are certain code paths that never really kind of get tickled unless they're in the production environment, or somebody only comes in from Internet Explorer 7 in the production environment. We don't test for that thing anymore, right? But those are the kinds of things we need to be ready for. Those are the kinds of chaos that are actually going to happen to our system. And that leads to the last most important point. You automate those experiments and you run them continuously. So for instance, Chaos Monkey runs 24 hours a day, 7 days a week in the Netflix production environment, randomly killing instances all the time. Why do we do that? It inoculates us against that particular failure. Pardon me. So chaos engineering in practice. We'll talk about a few specific pieces of software and what they mean. So we've talked about Chaos Monkey, right? Why would we do this to ourselves? It really can't be for savings, right? We talked about 800 million lines in that billing file. I really doubt killing a couple of instances is going to make a significant change in that billing file. And it's really not for entertainment purposes because we haven't gamified the UI for Chaos Monkey yet. So let's go back to our 4 steps. Our initial hypothesis with Chaos Monkey was that the loss of a single instance should not affect your application's capability to run. Because we're all going to lose instances, right? Amazon promises us instances will go away. They even email you to tell you they're going to go away. And if you're like everybody else, you filter those emails and never see them, right? Chaos Monkey lets me ignore them because it doesn't matter if an instance goes away. It doesn't matter if it's a planned retirement. It doesn't matter if it's a bad piece of hardware. It doesn't matter if it's a bad piece of automation. It doesn't matter if it's an engineer that clicked on the wrong thing. My application still behaved properly because Chaos Monkey runs all the time, so they're inoculated against the loss of a single instance creating any kind of problem for that running application. So Chaos Monkey kills instances. We had another hypothesis. We should be able to serve any one of our global customers from any of the 3 Amazon regions that we run in. So it led to a bit of a corollary. We should be able to dump an Amazon region and not have it affect our running applications. Overall, our customers should not notice. Some of you have heard of Chaos Monkey. This is his big brother, Chaos Kong. Chaos Kong virtually blows up an Amazon region. And we practice this regularly. At least once a month, we evacuate one of the Amazon regions. We pretend that it failed completely, and we serve all of our customers, all of our traffic through peak and through trough from those other two Amazon regions. And it's all automated. Those target regions scale up. Data's already there. There's no loading data from backups. The data is hot. The caches are warmed. All the services are ready to go, and they know how to behave when extra traffic shows up. So maybe you've noticed we've already varied another real-world event, right? Sometimes those events you want to plan for are successful events, right? We get additional traffic. We're being successful. We don't want to be victims of our own success. So not only does this allow us to prepare for that regional failure, each one of my regions know how to handle spikes in traffic and still serve my customers. This is the logo for a new system called CHAP. This is our chaos automation platform. Previously, some of our chaos experiments had a bit of a wide blast radius. For instance, one of my favorites is Latency Monkey. Latency Monkey sits in between 2 microservices and goofs with their conversation. It either slows the conversation down or it injects errors, it causes problems. And what we're testing for in that case is if microservice B is talking to microservice A, and microservice A is having a bad time, I want microservice B to behave correctly. I want it to understand how to go into a failback mode or to serve different data or just how to behave differently without human interaction. However, Latency monkey is a bit broad because we're affecting the entire running application. The vast majority of the time, our applications do fine. They back away, they gracefully degrade, and they go on with what they're supposed to be doing. Occasionally, we learn that there's a microservice that wasn't particularly ready for that series of errors, and it falls over. Kind of a wide blast radius for me to kill an entire application in a region. Fun to watch, but a little expensive. So what the Chaos Automation platform does is it allows a service team to get the same kind of learning with a smaller blast radius. So imagine, if you would for a moment, what you'd really like to do in this kind of testing. I'd like to have my application continue to run, and I'd like to start up 2 more clusters of the same code, exact same size, same instance type, and we're going to call one control, we're going to call one target. We're going to affect the target cluster in some way. And now we're going to take production traffic, and we're going to send the same amount of traffic to those 2 new clusters. Small amount of traffic, the majority of our regular traffic still going to our other application. And the advantage this gives me is I now have 2 running clusters taking production traffic, generating metrics and information that I can do a one-to-one comparison to. I can see exactly how that application behaves when that problem exists. When I'm done, I can turn them off. Traffic shifts back to my main application, and now I have those metrics ready to go to compare to understand how my application behaved. CHAP automates that. So all of our service teams can very simply ask that question, what happens when this service I'm dependent on goes away? They click a few buttons, CHAP puts it together for them, they get that information, they get that chaos learning at a much smaller blast radius. So that's CHAP. There's a lot more information about chaos engineering as a discipline at principlesofchaos.org. And this is not only a Netflix thing. Lots of other companies participating in chaos engineering as a discipline. So, how does chaos enable big and fast at Netflix? It enables resiliency. A lot of those problems that we know are going to happen, increases in traffic, errors, latencies, applications misbehaving, instances going away, are handled because the systems are effectively trained on how to handle that information. We don't have to page anyone, we don't have to wake anyone up, we don't have to wait for that time to go past waiting for an engineer to get involved. The systems effectively repair themselves. So chaos enables resiliency. Something else we talk about, intuition or understanding your operating system, right? Some metrics are rather simple. This number should never go above 20. Easy to understand, I don't need a fancy visualization for it, I don't need a graph for it, it's easy to test for. Shouldn't go below 100, same kind of thing. However, as we start to get more and more microservices generating more and more metrics, that becomes a little bit more difficult to keep up with. So you end up with an explosion of dashboards, an explosion of metrics, lots of different kinds of problems. And we get to a point to where we understand that that information is encoded in such a way it's a little difficult for our brains to deal with. So what if we could invent a suit loaded with electrodes, thousands of them, and we're going to wire those up to the behavior of microservices and metrics. And then whoever's on call gets to wear it. We call it the pain suit. Because if you're on call and all of a sudden you kind of get that twinge in the left shoulder, I know exactly that microservice X is latent, and yeah, there's the right knee. The other service is going to fall over. I know viscerally what was going on because I've wired all of that data right into my pain receptors, right? Into a way my body understands. Now, we haven't actually built a pain suit, at least not yet. We decided to try something else first. So we invented a framework called Visceral. And Visceral is a visual framework. We're going to wire into your visual receptors instead of into your pain receptors. But we're going to encode the data in such a way that your brain understands what to do with high data at high velocity. So our brains are really pretty impressive, and they understand certain things intuitively very well. So if we could take that data and present it in that format, all of a sudden understanding a complex microservices architecture that is constantly changing and constantly moving and streaming those millions of hours and having those billions of interactions becomes easy for me to understand. So, this is Visceral. This is just showing our global internet traffic going to the 3 Amazon regions. And you can see that US East there gets a little sick. So the first thing we do is we start bouncing that traffic out of US East. We wait for DNS TTLs to update. Now we're serving all of our global traffic from the other two regions. As soon as East becomes healthy, we back it off. Now, I didn't have to train you on this at all, and you already got an idea how much traffic was going where, and that maybe red is bad and there's more going in this direction. So you're able to viscerally understand those millions and millions of interactions going on every second. So we can take that a bit further. So here's the view that we saw before, but that was just for global internet traffic. I mentioned sometimes a region may get sick. It'd be nice to be able to see the same kind of thing inside of that region. Understand those complex sets of calls between microservices, how much traffic is going where there might be problems, and what services may have a problem. Again, without any additional training or information or a big block diagram to show you our architecture, you see this, you already know where the problem is, and you get an idea how my systems flow. So Visceral allows you to take that complex, high-speed, high-velocity data and wire it into your visual receptors in such a way that people can understand. So Visceral, along with a few of the other things I've noted and will note, are open source by Netflix, and you can find them at netflix.github.io. We figure if we've bumped into a problem and we've had to solve it, there's no reason we shouldn't share this with everybody else so you don't have to solve it again. So how do tools like Visceral enable big and fast? It enables simple and easy insight. You get that gut feeling, that intuition about the behavior of a system. What else? Deployments. I mentioned earlier it's no good if we're not available and we can't get these fancy new features and things out to people. Same thing. If that software is built, we need to be able to get that software out into the production environment and make it easy for the people that are building that software to get that out. It's one of those things that sounds like a simple process, but if you've ever had to deploy or do release engineering, there are lots of small variable pieces, not only to get your new code out there and running, but then to see it and understand it once it's running. So Netflix created Spinnaker. Spinnaker is our continuous integration and deployment environment. It's also our cluster management system, and it's the general lens that most Netflix engineers look at Amazon through. So, for instance, here's what Spinnaker looks like. This is a piece of software called API Production, really creative name, running in the Frank account, which is creatively named. Now again, without much training, you can see there are instances there. You can see ASG versions. You can even see ELBs are involved. You can see that some of the dots are not a green color, so maybe there's an issue going on there. And there's some information there on the side about what kind of instances we're using. You got all of that very quickly, and I didn't have to tell you about it. I could have stood up here silently, and you would have been able to deduce that same information about a system with which you're not intimately familiar. I mentioned cluster management. So there's some simple things you might do with a cluster, right? You may resize it, you may clone it, you may disable it, you may destroy it. One of my favorite ones there is at the top. It's called rollback. We encourage people to do red-black deployments, or green-blue, or brown-orange, or whatever the colors are this year. So when they release a new version, we keep the old version around for a while. Rollback makes it really easy for us to react to some amount of bad code getting out into production. So what would happen? What does that look like? So here you can see our API prod application has two versions. Version 341, which is currently green, and version 340, which is gray. Gray is dormant, green is operational. Let's assume we've gotten to this deployment, and we find out version 341 is really, really bad. We want to be able to get back to the other version as quickly as possible. It's really rough. You click rollback. The system manages re-registering version 340, making sure those instances are ready to go, shuffling traffic over to them, turning off version 341, and optionally tearing it down. So I'm now able to give people a way to save our customer experience from what is typically a pretty nasty thing to have happen with a single click. I think we can do better. There's a key idea behind Spinnaker. It's what we call pipelines. Pipelines allow you to effectively describe what your perfect deployment scenario would be once, and to have that happen the same way over and over and over. It's the hope we've always had for deployment and continuous integration tools. So for instance, here you can see a pipeline. We bake a new image, we verify the bake went okay, we run the unit tests, we run the integration tests, we launch a canary, and then we tap an engineer on the shoulder and say, hey, give me a go, no-go for shoving the rest of this back out into production. That's pretty nice, right? Canary doesn't do well. We only got one of them out there. We didn't have the same version 340, version 341 bad scenario to deal with. I think we need to do a little bit better than that. What if I could say, launch that canary, give it some production traffic, analyze its behavior, compare it to the rest of the running population, and give it a score. And if it doesn't score at least as well or better than the current population, just stop, right? That's kind of our mental map for regression testing. I want to make sure I'm at least as good, if not even better, than what's already running. We can build that into the pipeline. So that will happen every time. How about going a step further? Sometimes it's not bad code deployments that cause us a problem, but potentially deploying into an environment that for one reason or another should not have code deployed right now. How about I throw a check in there to check the environment before I push new code out into it? Maybe we're doing one of those chaos Kong things, or we know there's a problem, or we don't have all the reserved instances we tend to have. Now my automated pipeline understands how to check that and how to stop. I mentioned you can integrate tests. We want to have a lot of tests, and sometimes it takes a while to run all of those tests and run that canary. What if that process ends at 6 o'clock at night? Well, for us, that's one of our peak times, and unless it's really important, I don't necessarily need to be deploying during peak time, so we can create a window that says once you get to this stage, check the time. If you're not within the time window, just wait. It'll come around again, and you can deploy again. So Spinnaker and its pipelines allow our engineers to describe that perfect deployment once, and then all they have to do is commit code, and the pipelines manage the entire rest of the process for them. It's another piece of open source software that's available to you. It also integrates with Slack so that it can chat at you and tell you what it's doing on your behalf. So how does a tool like Spinnaker enable big and fast? Really, it enables velocity. We bring in software engineers, and we want them designing systems and solving problems. And that's where we want them to spend their time and focus. We don't need everyone to spend a lot of time learning how to be a release engineer. So Spinnaker enables velocity. It allows our engineers to continue going fast. Netflix is also poly lots of things. We have lots of languages at Netflix that we have things running in. Here's a sample of a few. You'll see JVM languages, you'll see Python, you'll see Node, you'll see Go. There's a lot of them I didn't even get up here. One of the things we do when we hire people is we hire smart people and we expect them to do smart things, and we get out of their way. We don't believe in having this constricted set of options for you to pick from. Because if I can't in any way understand every possible problem that's going to be coming at us, how could I tell you what systems are best possibly going to solve that problem for you? I'm paying you money to solve problems. You pick what is best to solve the problem. So we're poly lots of things as far as languages and libraries go. We're poly lots of systems. We run Linux systems, we run BSD systems. If you think about some of the devices are on, we have developers working in the iOS and tvOS worlds and the Windows worlds and the Androids worlds. Pardon me. Now we do, as things become more popular, add more ease of tooling and integration to certain languages. So we do have the concept of the paved road, but we allow people to go off-road if they so choose. They may have to do a little bit more of the work on their own. But overall, this enables choice. Because I want those engineers to be able to solve those problems as quickly as possible, to be able to design those new features and get them in front of our customers as quickly as possible. So we do that. We enable big and fast in this case by enabling choice. Containers are a pretty hot topic. I expect everybody's heard of containers. And we are a talk on the DevOps track, so we all have to say the appropriate chant, right? Docker, 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 Docker. Docker. So we've adopted containers. But one of the questions we deal with is why containers when really EC2 instances are already a container of their own. They already provide isolation. They already provide security and bundling of resources. So why would we go that direction, especially when you see we have a lot of tooling already created that takes advantage of the EC2 instance environment. And you've heard a lot from Netflix about microservices. If you haven't, we have a lot of microservices. We also push the idea of immutable infrastructure, right? We don't use configuration management. We don't have large Chef-like things or Puppet-like things or Ansible-like things running out there in the environment. We believe that you bake that AMI, that's what goes out, and you make a change, you bake a new one. Kind of works with containers, but it's still a little different. So if we already have an isolation container, if we already have tooling that supports it, why would we be adopting Docker? Again, it's not really a budget move. You know, I could pack a few more processes onto instances, but what percentage of that greater than 100,000 instances and 800 million lines in that file am I going to save by, you know, running a few node processes next to a few Python processes? It's not, you know, it's not going to help me a whole lot. It's not really an optimization play. We've done a lot of work to make sure that we understand which instance types work best for our software. Part of that canary process, we test different instance types, so we know from an instance standpoint, from that container standpoint, what is going to serve that software best. So it's not an optimization thing. It's not an isolation thing. So why would we choose to go the direction of containers? Simply because not every problem we run into is a nail. We run a lot of those production services, those microservices we talked about with immutable infrastructure, and that's worked well for us for a long time and does to this day. However, that's not the only thing we do. We have lots of tooling efforts. We have batch processing efforts. We have different kinds of data efforts. We have testing efforts, all of which a container environment makes a lot more sense for. So we wanted to be able to provide that. So we just container all the things, right? No, we don't just container all the things. Because we need more than just, you know, if you install Docker on your laptop, I'm sure it'll be fine, right? We said we have a rich environment. We have tooling and systems that understand the EC2 environment, whether it's those metadata endpoints or the other hundreds of tools that we regularly run, whether they're metric systems or data systems or management systems or service discovery systems. So we can't just say install Docker. So it can't just be Docker by itself. It has to be Docker and things that do deployment support and integration and scheduling and all of those kinds of things. So we developed a system called Titus, and Titus does these things for us. It's integrated into Spinnaker. It's integrated into our metric system. It allows our engineers to write their software and get all the expectations that they would get in running on an instance and running in a Docker container. So why do that when other systems exist? We have Kubernetes, we have Mesos, we have Swarm. Those other cluster or container cluster management softwares exist. So outside of just the convenience of integrating, what else would there be? Well, a lot of those systems were designed and grew up in the data center, and they're running containers on metal. We don't have any data centers. We started in data centers many, many years ago, and in 2010 or so, we made the decision we're going to move to the cloud. We'd like to have a partner take care of that undifferentiated heavy lifting. Undifferentiated heavy lifting being those things that have to be done but don't provide any advantage in really what our core business is, and that's getting you to press a play button and find, you know, some new entertainment that you enjoy. So we found a partner in Amazon that would handle all of that heavy lifting for us. So since we are completely in the cloud, minus that CDN that we talked about, it's tough to rely on a system that's really partially data center thinking. Now, there are newer cluster management systems that are very cloud-oriented. However, many of those are more platform as a service kind of oriented. And we didn't want to have to change networking assumptions and metric assumptions and configuration assumptions for hundreds of thousands of instances for the benefits of containers. So that's why we came up with Titus. We run Titus on Amazon, and we're going through steps now to integrate with ECS so that ECS becomes part of Titus. So how does Titus enable big and fast? It enables options. There are workloads for which containers are a fabulous choice, and there are workloads for which instances are a fabulous choice. I want my engineers to be able to make that single button choice inside of Spinnaker and get the system that best serves their need. So Titus enables options. Something else that's important to us, partnerships. You may have heard we use a little bit of Amazon. We use a lot of the oranges and some of the greens, a few of the reds, right? That's that undifferentiated heavy lifting. We use a lot of Amazon services, and we look forward to using more in the future. Because they handle things for us that, again, are undifferentiated heavy lifting, that I don't want my engineers to have to be thinking about. If I hire someone and it's their job to write billing code and integrate with banks, do I really want to teach them about ELB configurations? Load balancer, the best way to get your traffic through the load balancer and get distributed over to your system, or maybe, you know what, we need a queuing system, we should run our own. No, we don't run our own. So what does that do for us? How does that enable big and fast? It enables focus, allowing people to use EC2 instances, SES, SQS, all of that list, the purples and the greens and the oranges and the yellows and the reds. It allows those people that are focusing on Netflix business problems to continue to focus on Netflix business problems and still have an excellent infrastructure upon which to run their software. So something else that's important. Culture is important. You've heard me mention a few things about some of the assumptions we make about the people we work with. We hire smart people and we expect them to do smart things. Culture is very important to Netflix. We talk about it. We tell people about it. People come in to interview, we expect them to have read about it, and then we ask them questions about it. So what are a few of those features that enable big and fast? So there's values, right? Now some companies write values, on the wall in the lobby, and they say things like integrity and respect and excellence. Those words were written on the walls of Enron, right? We all know how that ended, sadness and jail time. So when I say values, what do I mean? The values we look for are the behaviors and proclivities in the people you work with. Those are what you value. Those are what you look for. And they're reflected by the people you hire, the people you promote, and the people that you ask to leave. Those are your actual values. Another thing people at Netflix talk about is freedom and responsibility. We hire smart people and expect them to do smart things. And we also find that smart people have a tendency not to do well when micromanaged or completely contained. And you'll see that came out in some of the other things that we talked about. We don't specify language choices. You log into Spinnaker, guess what you see? Everything. So we want people to have freedom of choice. And we're looking for people that are the kind of people that take responsibility. They don't wait for it to be given to them. Because this is the kind of environment we need to have to operate at this velocity and at this scale. And you have to be able to trust that those colleagues you have do that. Something else we talk about, context, not control. So my example here, managers at Netflix. I have one of them. They've given me a few over the years. What do I need that manager to do for me if I'm one of these people that's doing the freedom and responsibility thing, right? I need context. I need information about what's going on in the business, about the decisions that are being made, and about what other teams are doing and the kinds of strategies they have. I need that information brought to me. Why do I need that? Because I need to be able to make good decisions. I don't need to be told what to do. We're not a top-down company. My work isn't scheduled for me. I'm presented with problems, or more often than not, and sometimes to my own detriment, I go find problems and I try to solve them. So it's the job of the manager to do context, not control. So why do we talk about that? That kind of adherence to culture, and talking about culture, and making sure people understand the culture, making sure that when we hire people that they can succeed in that culture, we enable success of the organization overall by being careful about our cultural choices. So Netflix enables big and fast by enabling resiliency. Things like those chaos tests and best practices. I make sure that those microservices that come up and run and go through version changes and config changes understand how to behave and how to rescue themselves, how to self-remediate in a turbulent production environment. We enable big and fast by enabling insight, whether that's something like Visceral or Atlas, which is our big time series metric system. About 3.3 billion time series per minute go through that system so that people can collect data and instrument anything they want. We give them insight to a large, complex system. We enable big and fast by enabling choice. We make sure that people can pick the tools and the software and the systems that will best solve a particular problem. We look at partnerships. We enable focus. So if you come in to solve a certain set of problems, that's where your time can go. You may notice there's a common theme here. Netflix focuses on doing things and making choices that enable people. If you have questions, you can come see us at the Netflix booth. We're at number 720. I've mentioned our culture. We have a culture deck. It's a large presentation. You can find that at jobs.netflix.com. It's been called one of the most important documents to come out of Silicon Valley. Yay, Netflix. You can also find that at jobs.netflix.com along with jobs@jobs.netflix.com. It's one of the other things we need our managers to do is we need them to find us those stunning colleagues so that, I can do less. No, do more, so I can do more. Thank you, everyone.